Hey, it's me, Steve. It is July 12th, 2017. Time is 18:31. It's 79 degrees Fahrenheit out. It's humid as hell. For work today, I actually got to hang out at the LaPorte County Fair all day. Oh yeah, real quick too. Does anyone know what I could fill? I need 315 cubic feet of really cheap material to fill that pool hole. And, compost is not an option. Anyway, I digress. This is a Geo-Rant, and today I'm going to talk about rifts and how rifts, referring to plate tectonics, where continents, as if you're looking down on a map view, where they split apart and move apart. I am going to talk about how rifts tend to form in similar locations. Probably because they're zones of weakness. The exact mechanics isn't known, but there's one perfect example about 480 miles north of me called the Mid-Continental Rift. Now, not all rifts are successful. The Mid-Continental Rift, at least where it exists right now, is a failed rift. The North America in the Lake Superior region, and it actually extends down to Ohio to what we call the Grenville Front, and then goes under there, and we don't know anything about it. It goes up, fills the Lake Superior Basin, comes down, and goes down to like almost Oklahoma on the subsurface. So this huge rift, and it was around actually rifting for about, I want to say 15-20 million years. It began rifting about 1.2 billion years ago or so, and ceased at about 1.08 billion years. So we're talking Precambrian rift here. But for some reason, this rift failed. It started doing what rifts do. Now I'm looking cross-sectional. The continent split, and rift formed in the rock here started dropping down. Volcanics started coming up. You got lava flows, and the continent kept splitting. And if this process continues, what happens eventually, this opens up wide enough, the ocean comes in, and then you get something like the Atlantic Ocean. But it didn't get that far. The ocean didn't even come in. It stopped right before that. And the traditional theory is that the Grenville Front, which are the ancient Appalachians, not the Paleozoic ones, the ones before that, that when that microcontinent attached to Laurentia, which is another name for old North America, that shut it off. There are some people now who think that part of it may have been successful, and a part, Amazonia, which would basically be Brazil, actually broke off and moved south, but that's still iffy. It's just in the beginning stages. But so this rift, why did it form there? Well, the funny thing is, in almost the exact same spot 2.5 billion years ago, North America did successfully rift in that area, and part of it sailed off to become part of something else, actually probably a part of what is now Antarctica, but a lot of snow and ice there, so it makes it kind of difficult to confirm that, but there are metasedimentary rocks at that right time to do that. And this is the rocks that form this successful rift are called the Huronian supergroup. I've talked about them before. You got a classical rift passive margin development there. You've got lavas at the base, volcanics at the base, then you just got kilometers and dozens of kilometers and dozens of miles of sediments on top. And so we know that was a successful rift. Actually, a piece of it moved off to where Wyoming is. There's proper age equivalence there too. So it successfully rifted 2.5 billion years ago, and there's a lot of interesting things that happened that time. That's the first time modern plate tectonics appears in the geologic record. We had at about 2.45 to 2.4 or 39 billion years ago, we had a series of ice ages that's preserved there. We start to see the first red beds near the top of the supergroup. In the top group, the base of the top group, which is called the Cobalt group, which consists of the Gauganda Formation, which is where we not only get a bunch of till, we get the first red beds. and that tells us that we started getting oxygen in the atmosphere. This is known as a great oxidation. GOE, great oxidation event. I can never say that word. But anyway, just look it up. GOE. Anyway, so rifts tend to form in similar places, and the good thing about having the Huronian supergroup and then the mid-continental rift, or the Keweenaw supergroup from a lithostratigraphic nomenclature, is that if the mid-continent rift had been a successful rift, we might not know exactly what we know about, you know, the evolution. Plus the entire south half, Midwest and southern part of the U.S. would be somewhere else now. But it's just interesting. It's one of those things that you notice in geology, is that new rifts tend to form in old rift spaces where rifting is stopped and you know, something else has happened. But something else happened between 2.5 and that 1.2 billion years. And about 1.8 billion years after the area of Lake Superior had land to the north, but to the south it was basically open sea. And then you had the you had two microcontinents collide and what's called the Pinocchian orogeny, and we have Forearc Basin sediments and lots of volcanics and stuff like that. So yeah, so plate tectonics in this one little area within 300 miles of Lake Superior is just a geologic treasure trove of tectonic history. But anyway, that's it. Hope you learned something.